Have a good day. Today's topic is about.
Before getting into the topic, click on subscribe button of our Qopikun channel for more information, and please do comment us for any clarification and improvisation. Stay tuned. How, when, why to demand quality functional deployment.
What is QFD?
QFD is a quality functional deployment flexible tool that uses a system to implement customer requirements and directly related engineering requirements by prioritizing company activities, initiatives.
History of QFD.
QFD was developed in Japan in the late 1960s by Professors Shigeru Mizuno and Yoji Akao. At the time, statistical quality control, which was introduced after World War II, had taken roots in the Japanese manufacturing industry, and the quality activities were being integrated with the teachings of such notable scholars as Dr. Juran, Dr. Kaoru Ishikawa, and Dr. Feigenbaum that emphasized the importance of making quality control a part of business management, which eventually became known as TQC and TQM.
History of QFD. The purpose was to develop a quality assurance method that would design customer satisfaction into a product before it was manufactured. Prior quality control methods were primarily aimed at fixing a problem during or after manufacturing. The first large-scale application was presented in 1966 by Kiyotaka Oshiyumi of Bridgestone Tire in Japan, which used a process assurance items fishbone diagram to identify each customer requirement, effect, and to identify the design substitute quality characteristics and process factors, causes, needed to control and measure it.
Advantages of QFD.
Point 1. Create a customer-friendly environment in the workplace.
Point 2. To document the routine decision-making into the process.
Point 3. It ensure a methodical flow from the customer.
Point 4. It helps to establish priorities and planning effectively. 7 Basic tools of quality.
Quality have many names for these 7 basic tools of quality, first emphasized by Kaoru Ishikawa, A and the further of quality circles. Start your quality journey of these tools, and have a name for them too. Indispensable. Cause and effect diagram, also called Ishikawa or fishbone chart, identifies many possible causes for an effect or problem and sorts ideas into useful categories. 2 Check sheet, a structured, prepared form for collecting and analyzing data, a generic tool that can be adapted for a wide variety of purposes.
3 Control charts, graphs used to study how process changes over time. 4 Histogram, the most commonly used graph for showing frequency distributions, or how often each different value in a set of data occurs. 5 Pareto chart, shows on a bar graph which factors are more significant.
5 Scattered diagram, graphs pairs of numerical data, one variable on each axis, to look for a relationship.
7 Stratification, a technique that separates data gathered from a variety of sources so that patterns can be seen. Some lists replace stratification with flowchart or run chart. Advantages of QFD.
Point 5 Promotes teamwork and increases organizational ownership. Point 6 Promotes risk, threat and opportunity associated with alternative win strategies and technical approaches.
Point 7 Reduces overall cycle time and downstream changes.
The basic QFD house of quality matrix, what and how concept.
The how is about critical parameters, design features, etc.
The what is the requirements, care-abouts.
Completing the QFD matrix.
Point 1 Relationship strength between each what and how it is scored.
Point 2 Hows with highest total weighted scores are used to precede design decision.
How requirements flow down.
One method of determining the maximum utilizing of points in a product or service that ensures your design addresses the features that confirms customer satisfaction is the waterfall relationship, as shown below in the next slide. How to become what as QFD is flowing down. In this you can see the graph of customer needs versus requirement matrix system features, and systems features versus system design matrix. Design features against design matrix design features. Design requirement against product characteristic matrix. This graph ensures your design addresses the features that confirms customer satisfaction is the waterfall relationship, as shown in the slide. When to use fishbone diagram.
Point 1 Fishbone diagrams, also called Ishikawa diagrams, herringbone diagrams, cause and effect diagrams, or Ishikawa, are causal diagrams created by Kaoru Ishikawa, 1968, that show the causes of a specific event.
Point 2. Common uses of the fishbone diagram include product design, quality, defect prevention, and identifying potential factors causing an overall effect. Each cause for imperfection is a source of variation. When to use fishbone diagram. Point 3 Causes are usually grouped into major categories to identify these sources of variation, are people, machine, measurement, method, environment and material. However, they should be set based on the individual process. When to use fishbone diagram.
Point 4 The concept was first used in the 1920s and is considered one of the 7 basic tools of quality control. It is known as a fishbone diagram because of its shape, similar to the side view of a fish skeleton. Point 4 So when should you use a fishbone diagram? Use it to explore all the possible or root causes of a problem, uncover bottlenecks in your processes, and identify where and why a process isn't working.
A simple how-to follows.
1. Prepare a flip chart or an overhead transparency of the following fishbone format sample.
The fishbone diagram shows the process carried out by
Operator, environment,
material,
Machine, method,
output and specification of desired result. A simple how-to follows.
Step 2. List the problem, issue to be studied as the head of the fish, the right side of the diagram.
Label each bone with an identified major cause category. These, or others, may be used or combined. Major cause categories to consider. 4 M's, methods, machines, materials and manpower. 4 P's, place, procedure, people and policies. 4 S's, surroundings, suppliers, systems and skills. A simple how-to follows. Step 5. Brainstorm potential causes of the problem. As possible causes are provided, decide as a group where to place them on the diagram. It is acceptable to list a possible cause under more than one major cause category.
Consider combining small branches onto larger ones.
Consider splitting up large branches into smaller ones.
Step 6. Review each major cause category. Circle the most likely causes on the diagram.
Step 7. Review the causes that are circled and pursue each line to root cause.
Step 9. Reach an agreement on the most probable causes. An example of a wiring issue is shown below. Please carefully observe the fishbone diagram and see how the fishbone shows the problem in the chart.
Manpower.
Wire string too tight or too loose.
Machine.
Material. Tool pin wear. Measurement.
Hot tool.
Inaccurate measurement. Wire frame not flush to frame.
Environment. Wireframe not seated.
Now you can follow us on all like
Facebook, Instagram, LinkedIn,
Twitter. Catch us on YouTube and don't forget to like, share and subscribe. Awaiting your warm wishful presences in all our social media.